Now let's discuss CodeChef 156 contest even numbers hate question. The question says that an array is given of size n and we need to build a prefix array. I hope you all know about what is prefix array. If we have A1, A2, A3 and A4 as our array, our prefix array looks like first element will be A1 as it is. Second element will be A1 plus A2. That means till second element, what is the sum in the array? And third element would be till the third element, till the third index, what is the sum of previous indices? And for fourth, it would be A1 plus A2 plus A3 plus A4 in this way. So we have to build that array. And it is mentioned in the question that the person who is building the prefix array hate even numbers. And he wants to make sure that in the prefix array, maximum odd numbers should be available. Maximum odd numbers should be available. That means if we are building an array in this, we have to maximize the odd numbers. And here a condition is given that we can rearrange the array. Rearrange the array. The original array. The array A we can rearrange. That means we can change the positions of elements to get this prefix array with maximum odd numbers. Let's see the constraints of this. What are the constraints is n lies between 1 to 100. That means number of elements in the array will be 1 to 100. And the array elements will be also from 1 to 100. These are the constraints. And let's see this using an example and make some observations to bring some optimized solution. The brute force solution for this would be check all the combinations. Check all combinations. That means all rearrangements. We have to check all the rearrangements and do the operations. And how many odd numbers we are getting, we have to return that, the maximum number of odd numbers. But let's make some observations to make our thinking ability more powerful and also the code less. Let's see this. If we have to build a prefix, and if we want to get an odd number by summing up few numbers, like two numbers, what will be the uh, value for this? If we take one odd number and one even number, we'll get an odd number, right? In other cases, like odd plus odd or even plus even, we get even numbers here, right? The only possibility which we get odd number by adding two numbers is odd plus even. That means one odd number and one even number. So let's try to do this with this example. That is 2, 3, 1 and 4. We already discussed that odd number plus even number will give the number. So let's take the first number as odd number. In this case, the prefix, let's say this will be the rearrangement of A, and let's write prefix here. If this is the case, the first element will be as it is in the prefix. So now what we have to do, we have to add this number with some number which is here. So what we discussed before, odd number plus even number will give an odd. So we have to place an even number here. Let's place 2 here. If we place 2 here, we got 5, right? Even here we got odd number. So if we have any other even number also, we have to place it here. So we have to place 4 here. What we got here, we got 9. Now, if we see, we are left with only 1. So we have to place that for sure here. So we can say that sum is 10. If we see here, when we are combining odd and odd, we are getting even number. So this will not be contributing to our answer. So how many odd numbers we have in this? 3. 3, 5 and 9. These 3 are odd numbers. So the maximum number of odd numbers we are able to obtain in the prefix is 3. Now let's see another example. 3, 4, 7, 2 and 3. If we see, if we apply the same above case, if we take first an odd number, let's take the first number as odd number. The first in the prefix also will be the same. Let's take an even number here. Now what will happen? The sum is 7. Now let's take again one more even number. The sum would be 9. Now we have only odd numbers left. That is 3 is done, 4 is done, 2 is done. We are only having 7 and 3. So we have to place that anyhow. So let's take 3 first, or even we can take 7 there. This order may change. That means if we want to place 2 here, we can place. And if we want to place 4 here, we can place. But I'm taking in this way. So let's proceed in the same way. If we do this, the sum would be 12, right? 12 plus, what is the next number? It is 7. If we do this, what will happen? This will contribute us to 19. How many odd numbers we have? 1, 2, 3, and 4. We have four odd numbers, right? We what we can say from this, we have to have at least one odd number to get the sum as like prefix sum values as odd, right? If we want to get prefix sum values as odd, we have to have at least one odd number. Let's say if we have all even numbers, let's say 4, 2, 4, 6, and 8, what will be the case here? If we rearrange also, the sum will be same. That means here it will be 2, 6, 6 plus 6 is 12. This is 20. Even we rearrange these values, we'll get the same even values, right? As this formula concerns, even plus even will give always even. So in this case, we have to return 0. That means no odd numbers are present in the prefix array. Let's see a case where everything is odd. That means every element in the array are odd. If we see this case, the sum is, even if we rearrange, we'll get the even numbers only. Let's see how. This is 1. If we add these up to, this will be 4, this will be 9, this will be 16, this will be 25. Here what we got? 1, 2, 3. We got 3 odd numbers, right? Let's make some observation here. If we see in the first test case, let me erase this and write that observation here. Now, if we see here, how many odd even numbers we are having? We are having that many odd numbers in the sum, right? How many even numbers we are having? We are having that many odd numbers in the sum. So we can say even count, like number of even numbers in the array, plus how many odd numbers we have here, 1 and 2. Here what we can say, how many odd numbers we are having? In spite of this, we have only one odd number contributing here, right? This is even, so we should not consider that. So we have one odd number contributing. That means odd numbers, odd count by 2. That means here we have 3 and 1. We have 2 odd numbers, but we got only one combination. If we see in the second test case, how many even numbers we have? Here it is 4 and 2, that is 2. Plus, here let's write this solution 2. Here we have 2 plus 1, that is 3. If we see here, even count is 2 plus the odd count by 2. We wrote odd count by 2, right? How many odd numbers we have? 3, 7, and 3. That means we have 3 odd numbers. If we have 3 odd numbers by 2, we are getting 1. But our answer is 4 here, right? Now what is happening here? If we see, the first odd number is contributing to one odd number. But after adding the even numbers, if we see, here, 2 odd numbers are combining to give another odd number. That means here odd and odd are contributing to one even number, and this even is combining with some other odd number and giving odd number here. That means a pair of odd numbers is giving us one odd number, right? So the pair will be calculated by this 3 by 2. And we also have one odd number here. So we have to add plus 1 there. Plus 1. If we do this, what will happen? Sorry, it's 2 plus 1 plus 1. That is 4, right? If we see in the next case also, as this is, we already said that at least one odd number should be present in our array. So this case will be default case where we have no odd numbers, even one odd number also. we have to return directly 0. If we see in this case, what is the even count here? That is 0. Plus, what is the odd count here? What is the odd count? 1, 2, 3, 4, 5. 5, right? 5 plus 1. Sorry, 5 by 2 plus 1. What will get? That is, 2 plus 1. That is 3. Did we get the correct answer here? Yes, we got it. Now, can we simplify those two formulas into one? That means this is one formula. Let's write in odd number by 2. This is one formula. Even count plus odd count by 2 plus 1. If we try to see this, even count will be as it is. If we see odd number plus 1 by 2, if we do this formula instead of once checking for even and odd, like when we have the odd numbers as odd, the number of odd numbers is odd, that is OC is odd. This is OC is odd. We are taking OC by 2 plus 1, right? When odd count is even, where is this case? See here, when odd count is even, we are taking OC by 2, right? Can we simplify how somehow? If we do OC plus 1 by 2, will it give the same number? If OC is odd, see, let's take OC as 2, that is even. When we take even, 3 by 2, this is giving 1 as our output. When we take an odd number, what will this give? 4 by 2, that is 2. In this case, the same thing we did. If we take this value and do 6 by 2, that means 5 plus 1 by 2, we got 3. And here if we see, where is this? Here. Here if we see, there are only two numbers, right? 2. 2 odd numbers plus 1 by 2, that is 3 by 2, we got 1. So this count is validated here. So we can simplify these two formulas into this formula. So what our code looks like, what our approach looks like. At the final stage, we are checking, first we are counting even values and odd values in the array. Let's say we are storing that in EC and OC, even count and odd count. Now what we'll do? We made an observation there that at least one odd number should be present to maximize the odd count. So if OC is less than 1, what we can do? Directly return 0, isn't it? Here we had only even numbers. In this case, we had only even numbers. Our output is 0. So in this case, when odd numbers are less than 1, we can directly return 0. If this is not the case, what we can do? We can directly write this formula, right? How many odd numbers we are having? Odd count plus even count plus odd count plus 1 by 2. We can directly return this value. And let's return this here itself. This is the pseudocode for the problem. If we see the time complexity, to count whether the values are odd or even, we have to traverse the whole array once, right? So that will take n complexity. After that, these if and else conditions will take only constant time, right? So the time complexity would be n, and space complexity would be also constant because we are not using any extra data structure. Thank you.